Welcome to our next video series. Now we're getting into the wonderful world of counting. And you might have thought yourself a master counter before. Now you're going to start to learn some of the arts or sciences behind doing some advanced counting, which you might think is really not that important, but yes, it does matter. And we'll try and explain that and show that in the next couple of video series that I'll be putting up here. First one, though, is permutations. That's going to be the first one. Now, trying to get into why we want to be good at counting. It's to answer harder questions. Things like, is it really worth it, yes or no, to buy a lottery ticket? Is it worth it to have a long password or a short password with, just the exclamation points and the @ symbols and all of those? And is it worth it to adhere to the social distancing guidelines? Is it actually that effective? Now, these questions right here are rooted mostly in probability. And so we're going to go, after we talk about counting, into probability. But in order to determine what's likely or probable or improbable, you first got to be able to list out the number of outcomes out there. And yes, one way you could do that is list out every single outcome. But in the case of the lottery ticket, there are hundreds of millions of outcomes. There are hundreds of millions of outcomes for long passwords, if not billions or trillions, depending on how many digits you're throwing in there. And that last one is mostly a probability question, but we'll get to that one too towards the end of the semester here, I hope. In any event, we do need to be able to count things when just listing out outcomes is just a little too much. So the first type of counting problems we'll consider is permutations, where order matters, or the sequence matters. And the core piece of everything we're going to do this semester, or related to counting at least, is probably going to be rooted in what's called the fundamental counting principle. And if I ever misspeak and call it the fundamental theorem of counting, you'll hopefully still understand what I'm talking about. The fundamental counting principle here. Very important, very useful, very helpful. And what this thing does for you is it will say, well, if I've got one thing I'm doing and there's so many ways of doing that, we'll say M, and I'm doing something else after that, and there's N ways of doing that, then for doing both things together, I just multiply the ways for the first times the ways for the second, and that's my total configurations for doing both. For example, this is always the go-to. In every textbook I've ever read about counting, this is one of the first examples. Suppose I've got some number of shirts, some number of pants, and some number of ties. Now, these are pant colors. And I want to know how many outfits I can make. Well, what I could do, if I hated myself, is list out every single configuration. Where I'd say, okay, dress one, dress shirt one. Goodness, this is not going to end well. Shirt number one, I've got pant one, tie two, tie three, tie four, and go 12 times there, 5 times there, 10 times there. And I would have literally thousands upon thousands of configurations. Just kidding. I can't do mental math in my head right now. I would have hundreds and hundreds of configurations. That's because I have 10 ways of picking a shirt. Once I've got my shirt picked, there are 5 ways of getting a pant color. Once I have those, there are 12 ties. And so I would have any one tie, any one pant color, any one shirt. And that's 10 times 5 times 12, 600 different outfits. Now, some of those outfits are probably going to be atrocious. We're not accounting for taste here. But the fundamental theorem of counting, or the fundamental counting principle, simply says that if we have unrelated things happening or independent things happening, we can take our number of configurations, multiply them together, and that will be our overall head count of configurations for the overall process. So we'll stop here. I've got another example for you to think about. We'll pick it up in the next video. Suppose I've got 4-digit codes, specifically the personal identification numbers for an ATM. How many configurations would I have for a 4-digit PIN? I'll show you in the next video.